Swayam Prabha. Digital India. Educated India.
Let's look at the example now. A company plans to hire people to fill up job vacancies. On an average, it takes about 6 months to adjust the labor shortfall. The desired level is 100 people. Very simple system where I know how many people are required. I need to spend some time to hire them. Hiring process takes time. In this example, it takes on average it takes about 6 months. We have to advertise and people will apply, and then later we make offers and some may join. Again, if still there is shortfall, again you have to apply for multiple rounds, because you are not getting at the same type of people. You need a range of people with variety of talents. So this is a very simplistic system based on that. So let us assume that the initial value is 0. There is nobody in the system yet. Desired value is 100. We need to build a SG model of above system. Ensure that model runs without error. Units are consistent and system starts in dynamic equilibrium. Let us take time as months, time unit as months. For simple reason is, I have already written that on average it takes about 6 months to adjust the labor. So if you are going to use time unit of months anywhere, then everywhere it should be time unit of months. So that makes our choice easy. That's why it's taken as months. And let us take the time step, simulation time step as 1. See, dynamic equilibrium is for physical analogy. Imagine a kind of a ball sitting on top of a hill. So at that point it is in equilibrium, but any small perturbation to it, it will start rolling down the hill. So it is at a point where system, when you simulate it, you find that there is no dynamics in the system. System is constant over time, and then when you make a small perturbation in the system, then system starts to change. Like if you imagine a pendulum, then dynamic equilibrium is pendulum is at rest. Unless you apply external force, it is not going to start moving. So before you start simulating, ensure system is at rest. Then we can start simulating. Then we will figure out whether are we at a kind of already at a equilibrium point where you will return to the same point afterwards, or are we going to settle at a new equilibrium? Those things become clear. Dynamic equilibrium is a point where the system has, there is no other perturbation in the system, and all values are kind of constant. I hope all of you have installed Vensim education version. Okay, first is let us click new model. Time step is already, units for time is already will be month, and time step is 1. So let us just leave it as it is. So this is what we are trying to model. So labor is the stock here, and net hiring rate is your inflow. We have an adjustment time coming in, labor shortfall, which is nothing but the difference between desired labor force minus the labor. Okay, so this is what we are going to model. I may use slightly different terms depending on what comes to my head. So we have labor. I am clicking outside, and then it's not click and drag, just click once outside and click once inside. Net hiring rate, desired labor, labor gap, adjustment time. Once it is done, then I am just going to connect them. The arrows can be straight lines, it need not be curves. That has no value to the model other than aesthetic aspects. So it can be just simple straight lines. You can make it, this curves look slightly better looking, that's all. It does not affect your model whatsoever. To connect it, you have to connect the arrow, say click on labor gap, it will draw a blue arrow. That's it. In the diagram I use, we can put the plus and minus signs. To do that, you can right click on the arrow and there is an option called as polarity here. In that you can say plus or minus whatever you want. So that will appear next to the arrow. So you right click it. You can get the plus or minus. I am just clicking the arrowhead and clicking. Adjustment time, it will be minus because we are dividing by adjustment time. Since adjustment time increases, net hiring rate will fall down and the direction is opposite. Again, plus minus are just for visual aspects. Now click this equation f of x is what shows to me. You will have something called as equation and f of x. Click that. So it will go black and white. It will go dark mode. That's, I think, common terminology these days. So once in dark mode, you click. Let us start with labor. You click labor. Let us start from the top. Name labor is fine. Type is level. As it was level or stock is same. So nothing to change there. Units. Unit is person. Initial value it asks. Then it's already integrating net hiring rate. We don't need to touch it. So we go to the initial value. Let's put initial value as 0. Let's click OK. Let us go to desired labor. Let us go to units. Again the units will be the same person. Here equation is a constant value. Let us start with the equation as 0. Okay. Let us put the desired labor value is also 0. Now let us go to labor gap. What will be units for labor gap? If you click the drop down, already the other units that you have already typed will come. By default, Vensim gives 2 units. One is DMNL, which means dimensionless. Other is the time unit itself, which is month. So then we have defined person. So this also has to be person. Difference of person is again person. Differences we want is desired labor minus labor. So if you click the variable here, the same will appear there. Okay. You click it once, or you can type it. It's up to you. But all the variables listed in this box, where I am pointing with my arrow, has to be used in the equations defined in this equations box. If not, it will throw an error. For example, if I just write it like this, labor gap is desired labor and click OK, I will get an error saying following inputs are not used. So it prompts you saying that there are 2 inputs, you are not used 1. So you click OK and then put a minus sign, put labor. Okay. Then we click OK. Let us move to adjustment time. Adjustment time, time unit, if you can see, type is already constant, it is not getting affected by anything else. So it automatically selected as a constant. The unit is month, we are measuring time in months and problem statement told 6 months. So I am just going to put a value of 6 into this. Okay. The last comes in net hiring rate, person per month. So net hiring rate is labor gap divided by adjustment time. Net hiring rate is units is person per month. The equation is labor gap divided by adjustment time. I am just going to save the model. So let us again all take a look at labor. Labor is units is person, initial value is 0, net hiring rate says net hiring rate, we just leave it. Go to desired labor, units is person, equation 0, we click OK. Labor gap, units person, equation desired labor minus labor. Adjustment time, units month, equation 6, just a constant 6, net hiring rate, units is person per month, labor gap by adjustment time. It is case sensitive and verb sensitive. Somewhere you use person, somewhere else you use persons. For it is just a string, it will say it is wrong. Units don't match. It is just a piece of software. It is not going to parse your English. So once you have got this, you can do model, check model. It should say model is okay. So now let us click simulate. It will ask data set already exists, you want to override, just say yes. Simulation is already done. Now you can select any, say let us select labor, that is a stock, and if you click the graph on the left menu bar, this one which is being highlighted right now, 1, 2, 3, fourth one from the bottom, you will get a straight line, there is no change in it. So the system will always be in dynamic equilibrium when what happens? When desired state and current state is the same, or when net flow is 0. When net flow is 0, then it has to be the same. In this case, so for example, if desired labor is 100, labor is also 100, then it will still be in equilibrium. No change will happen. So this is what is called as dynamic equilibrium. Over time, things are still in equilibrium, nothing is changing. So now we want to see what will happen when any of the stimulus changes. So let us go, open the equation, click desired labor and make the desired labor 100. Click OK. Let us click play, override data set yes. Now if you let us click labor, now you start seeing this nice goal seeking behavior, asymptotic growth has happened. So over time the discrepancy has been adjusted over time until the labor force reached its goal of 100%. Yeah. So this is entire graph. So let us see what happens. Just to visualize it better, I am going to change the model settings to, instead of final time as 100, let me keep it as say 30 final time step, and just taking the final time step as 30 to get a better resolution graph. Okay. So I can explain things. Okay. So this is the value of the stock that you should be able to see. Even if x axis goes 100 is fine, but so let us observe what happened at time 6. So your adjustment time, remember, it was 6. So all we are trying to see is what happened after one adjustment time went ahead. So adjustment time 6, the gap fulfilled is about say 65. So out of 100, 65 was fulfilled. Now let us see when time unit became 12. At time 12, the value is say about 88, I would say. I don't know the exact value, but I am just guessing, probably it is 88 here. At 6 it is about 65, or rather at time 6 about 65% was fulfilled, the gap was fulfilled. Now at time 12 total was at 88, which will be about 65% of the gap between 100 and 65. The previous time state was 65, 100 minus 65, about 35, about 65% of 35, that much percent would have been fulfilled at time 12. So at every time unit, at every interval of adjustment time, about 60% of the discrepancy or 65% of discrepancy gets fulfilled. and asymptotically it will reach its desired goal. That is how the scenario works in this model. Now let us take two different things. The top represents the labor, this net hiring rate. How I opened this graph was, I clicked the labor, I click labor and click this causes strip. Causes strip means it will plot this one and plot all the inputs into this. So that is what causes mean. To understand what caused the dynamics of labor to change like this, there was only one input, which was hiring rate, net hiring rate, and unlike your exponential growth systems, in this the net hiring rate is going to keep falling down exponentially. Things starts at around 16.5 or something, or maybe 16.5, and gradually comes down to 0. This is expected because at equilibrium the system has to reach net hiring should be 0, because once you reach the goal you do not need to do any further hiring. The goals are remaining constant. If you want to know the numbers, you just click labor and click this table time down. You will get time on axis and get the actual values which it computes every time. Okay. Then maybe I can show you a neat trick. So once you get this labor, don't close this window. Don't close this window. I am just resized it, moved it to the right. Now you just click somewhere here. Click hiring rate, and again click the same drop down. Then you will find that the hiring rate is also added as another column in the same sheet. So you can start comparing the values. So if you select multiple things and click the graph, both the things will be displayed. You can do one by one, or you can use shift. So first, if I do labor and net hiring, let us see what happens. I selected both. Now I am going to click graph. I get both the graphs simultaneously. So very simple features, but very useful. All I have to do is whatever variables I want, I use shift to select all of them and click that graph button. Then I get multiple graphs in one picture, so that I can see exactly how it changes. But be careful about the units, because here it uses left y axis and right y axis. Left y axis is used for stock, right y axis is used for persons per month. So if you have more variables, it will start to superimpose multiple y axis one on top of each other. Okay, so just be careful. We can try that also. Let us see what it does. Let us do net hiring, labor, labor gap. All three, other two are constants, I am not putting it. So it is up to our intelligence to figure out which graph is mapped against what, but you get enough evidence. It already shows here labor and bracket it says person, that means the unit of labor is person, labor gap is person, the same units are appearing in this graph here. So if you do not write the units, it will just show it as blank, so you won't know what is happening. Same thing, net hiring rate is a person per month, so it must be person per month. We know it is blue, it's already highlighted as you go here, it highlights. So there are these kind of subtle features which makes it very useful and powerful. Okay. Now let's we already done this. Simulate scenario when initial labor is 0, simulate scenario when initial labor is 200. Let us try that. So I am not changing anything yet. With 100 itself I want to know what it is. So okay. So when I click play, it will ask you this question: current data set already exists, do you want to overwrite it? You just say no. So here we can say labor 100. So labor initial level was 100. Let us click save. So that data set is now stored as labor initial 100. Desired labor stays at 100. Labor changes from 0 to 200, change labor to 200, initial value of labor to 200, desired labor continues to be at 100, desired labor goes to 200, then when I click simulate, again it will ask overwrite labor initial 100, you say no, do not overwrite it, save it as labor initial 200, oh boy, that should be labor initial 0 anyway, labor initial 200, even if you did not get overwrite, we will come back. Now observe the graph. So instead of approaching it from, we have not changed the bottom, I mean we have not changed the model, desired labor is 100, current labor is 200, that means effectively we need to fire people. So the net hiring rate here actually means I am removing from the system, but the same model works by just changing your inputs. As you can see, the labor is now falling to 100, it will be a, what can I say, mirror image of the graph that we got here. We are adjusting the discrepancy at every time unit, about 60% of the discrepancy is getting adjusted. Okay. If you are not able to do both the graphs, I will give the instructions again, I will write it and put it in Moodle, you can check out those instructions. Basically, before simulating, for each setting you give the under what it should be stored here in the top, you can see the name here, you give it and store it. So, and automatically all those data set will be alive as long as simulation is up and running, I mean your Vensim is open. So, all those graphs will just get superimposed. We can also see how the net hiring works. So, here as you can see, this was the people who were hired. In the first case, when the initial labor was 0, so we hired lot of people and then slowly reduce the number of new hires. In this case, lot of people are laid off and then as over time less and less people are laid off, then the initial value is 200. So, the system remained the same, we just changed the parameters and the model became even for letting people go, the same model was used. When you change the adjustment time, what do you think will happen? If adjustment time from 6 became 2, how do you expect the shape to change? But if adjustment time is lower, we must reach the goal sooner or faster, earlier, right. So, we can try that and go to equation, change adjustment time to say 2, run it, overwrite, I am just going to put no, labor initial 282, click save, go to labor, graphic, I am going to remove one of it, okay. I just removed these two lines. So, I am just putting two graphs, one when adjustment time was 6, which is the green one, and the red one when adjustment time is 2. The initial value of stock was 200, the goal is 100, both reaches the same goal, except as we expect, as adjustment time is longer, it takes longer time, or adjustment time is shorter, it has to reach the goal earlier, it is the same dynamics that we can expect, but the shape of the system continues to be asymptotic. So, if adjustment time is 2 months instead of 6 months, we just saw that. Okay. So, I have the graphs here also. So, when the initial level is 200 and adjustment time is 2, the initial level is 0, adjustment time is 2, of course, it will be mirror image except that you are approaching the goal from either the top or the bottom as the case may be, and as adjustment time becomes longer, it is going to take even longer to reach your goal. That is what this graphs are telling us, but as each adjustment time passes, we will be adjusting about 60 to 65% of the discrepancy. An exponential approach to goal happens, state of system reaches goal at diminishing rate over